Good morning, everybody. This assignment is for the week of May 18th. Like always, it'll go all the way through Friday, the 22nd. And you pretty much have all week, to finish up. There's no rush. But I think this will be the last assignment of the year that I'll give out. I think there's only a couple weeks left of like instruction. If we were in the real on campus, there would be just pretty much a week or two left because we'd be starting finals right about now if we were in school. But there are no finals, so don't worry about that. So I think I'll just take the last couple weeks to finalize the grade book. Just talk to students and see, hey, do you want to finish up this last work so I can give you credit? Just do all the little end of the year things, pretty much. So today, Pythagorean Theorem. We're introducing you to Pythagorean Theorem, which is going to be very, very important in high school. You'll see it more than 1 year. You'll definitely see it all the way through any algebra class you take, algebra 1, algebra 2. So one of the most important topics, Pythagorean Theorem, is what we're going to learn today. So there are 10 questions on the informal proof of Pythagorean Theorem, and there's 5 questions on demonstrating the converse of the Pythagorean Theorem. So let's get started. Preview assignment. Number 1. So number 1 says, the right triangle below has legs of length 10, which is A, and length 7, which is B. The hypotenuse is length C. So what is the hypotenuse? Let's back up a little. A right triangle, like you see here, you know it's a right triangle if it has a little square on the inside, meaning that there's a right angle made by the 2 legs. So there's 2 legs. The shorter leg is B, the longer leg is A. And then the hypotenuse is kind of this slanted side here, side C. 4 copies of this triangle are arranged as follows. The hypotenuses form a square of side length C and area C squared. Oh man, this happens every time. Okay, it actually worked this time. The hypotenuses form a square of side length C and area C squared. What is area? If you forgot, the area is space occupied by a flat shape. So we're talking about area a little bit in this assignment, just so we can learn our Pythagorean theorem. It's like leading us up to that. So one triangle, like they said, there's 4 of them now, and they're arranged so that the legs are side by side. The short leg of one right triangle is side by side by a longer leg of a right triangle. The same triangle, they're just 4 of them arranged side by side. So we need to answer questions below that relate to how A, B, and C are put together or arranged. So part 1 says compute the total combined area of the 4 triangles. Compute the total combined area of the 4 triangles. Okay. If we're talking about area of a square, I know they asked for a triangle, but if they're talking about area of a square, which they will here in a second, the area of a square is just you take the base, or you can call this the base, whatever you want to call it. They're all the same length, so all of these are really bases. Take the length of the base and multiply it by the length of the height. So since this one's, on the bottom of the square, usually we call the bottom the base, and then the part standing up is the height, right? So let's just use these 2 sides here, the left side and the bottom. The length of the bottom times the length of the height, right? But if you think about a triangle, a triangle. Imagine if I like drew some lines in here and I made this connect. Like another triangle, right? Doesn't that kind of look like another triangle if you follow? That is another triangle. Let me see if I could draw that for you. If I drew, and I'm not the best artist in the world, just to let you know. That's another triangle, same size triangle, and now it creates a square. That's a square. Um, so if we did that, we'd simply have base times height, and we'd have our area of the square. But we don't have the whole square. Let me erase that. We only have half of it. So the area of a triangle, if we follow that, if we had a whole square and we could do just base times height to get the area, and we know we only have half of that, then that's what we use for our area of a triangle, half base times height. So the base is 7. We could stand this up, or we could rearrange this triangle where 7 will be the base, 10 will be the height, or you do it the opposite. You can make 10 the base and 7 the height. It doesn't really matter. 7 times 10 is 70. But remember, a triangle is half of a square, so we need to take half of that. It's half base times height. 7 times 10 is 70. And if you take half of that, divided by 2, you get 35. So the area of one small triangle is 35 units. 35 units. And I would write this down if I were you. Just so you can remember. Okay, let's go back to part 1. It says compute the total combined area of the 4 triangles, though. So we need the area of that triangle, that triangle, that triangle, and that triangle. And that we already have the area of 1, right? So if we have the area of 1, which is 35 units, we just multiply 35 times 4. What is 35 times 4? 35 times 4 is 140. So the total combined area of the 4 triangles is 140 units. Hopefully that makes sense. Compute the area of the larger outer square is in part 2. So, okay, the larger outer square, we know, based upon what I said a few minutes ago, one side is the combined length of a short leg and a long leg of the right triangle. So just add them together. So 7 plus 10 is 17. 7 plus 10 is 17. 17, 17. Each side is 17 units long. And the area of a square, like we just talked about, is just base times height. So we just take the base, multiply it by the height. The base is 17 units. If we add a plus b, the height is 7 plus 10 if we add a plus b. So 17 times 17. What is 17 times 17? 289. 289. So that is the area of the larger square. So there's 4 right triangles arranged together side by side, and it makes a larger square. And then it also makes a smaller one on the inside, if you can see that. Just by how they're arranged, they make a small square on the inside. So, part 3. Use your answers in part 1 and 2 to find the area of the small inner square. Okay. We can find the area of the small inner square, but we need to use Pythagorean theorem at this point to do so. So, Pythagorean theorem says, let me write this down for you. Pythagorean theorem says a squared, oh, I told you I'm not an artist. Oops, let me erase that. That looks bad. That looks really bad. Okay, try this again. A squared, and that looks like a Z or something, but that's a 2. A squared plus B squared is equal to C squared. Okay, so that wasn't that bad. A squared plus B squared equals C squared, okay? So we have length A here. We have length B. We need to find we need to begin to start to find um, side C. So if you know what squared means, that means you take whatever number is in the place of A, just multiply it by itself. You're multiplying whatever A is by itself twice, right? So if it was 1, you just do 1 times 1. B, the same thing. You multiply whatever number is here for variable B, and you multiply it by itself. That's pretty much all you do. So we know what A and B is. We know A is, let me get my little writer out again. We know A is 10. Oh, Lord. This is bad. We know A, let's try this again. We know A is 10. Okay, so 10 squared. We know B is 7. So 7 squared. That is supposed to equal C squared. Perfect. So, get your calculators ready. What is 10 squared, or 10 times 10? 10 times 10 is 100 plus 7 squared. 7 times 7, I know, is 49. And that is equal to C squared. C squared is equal to 100 plus 49. What's 100 plus 49? 100 plus 49 is just 100 and... Uh-oh. Ooh. I hate to... Okay. 100 plus 49 is just 149. So C squared is equal to 1. Man, this is like the hardest thing to do in the world. C squared is equal to 149. So that's what they asked for from the jump on part 3. What is C squared? So that was one way to find C squared. I'll just give you another way just in case you'd like to learn it. So a different way would have been we could have took the area of the largest square. So we could have taken the area of this larger square, which we already found to be 289. It was 289. Excuse me. And we could have just subtracted out these triangles. If we're finding whatever this area is, right? The area of the smaller inside, we just take away all these squares, right? If we take away all the squares, all we're left with is the inner square, right? So the larger one was 289 units, the area of the larger square, and we just subtract these smaller triangles. So we know the 4 triangles combined, the area is 140. So we could have just said 289 minus 140 minus 140. What is 289 minus 140? 289 minus 140 is 149. So we know that the area of the small inner square is just you take away the larger area, subtract. I'm sorry, the larger area, and then you take away the combined area of the triangles. So take the larger area of the square, or the area of the larger square, and subtract the combined area of the 4 triangles. So 289 minus 140 is equal to 149. Wow, this is really like difficult. 149. And so it's the same thing as C squared. So this is what we got for C squared. It's the same thing as taking the area of the larger square, subtracting the combined area of the smaller triangles. And I'll tell you why. Because if you take, and on the inside of this triangle, each side is of length C. Each side is of length C. So the area is C squared. So we found the area, but we could have easily found the length of each side C by taking the square root. I think we went over this one time this year. To undo a square, you just take the square root. So to undo a square, you just take the square root, which whatever you do to one side, you have to do to the other. So then we come out with C is equal to, right? Because this square root symbol takes away this 2 right here. It just disappears. They both cancel each other out. So then we can take the square root of 149. Square root of 149 is about 12.2. 12.2, about. I just, let's round to the nearest 100. 12.21. 12.21. That is a length, about the length of one side for C. I just rounded. And so if we're talking C squared, the area of the smaller square is just base times height. So C squared is just 12.21 times 12.21. And that is about 149. So hopefully that makes sense. I know it's tough, you just watching me, virtually and hearing my voice and trying to follow along, but hopefully that you got one of those two ways. There's two ways you can pretty much find it. I think the first way might be easier because they just want C squared, right? And then C squared is just A squared plus B squared, pretty much. So you just square A, square B, and C squared is the sum of both of those. So C squared we just found out is, C squared we just found out is 149. And then part 4, they're pretty much asking you the same question. But before they worded it as finding the area of the smaller inner square. But now they're asking in terms of side lengths. So if we add the side lengths together, where side length A is 10 and B is 7, and then we square both sides. So we square both sides and then we add them together. We just found that. And we found that to be 149. And then lastly, part 5, use less than, greater than, or equal to complete the statement. A squared plus B squared is blank to C squared. In this case, you tell me. So let's look back up at side length A and B, because this can vary, and you'll see what I mean here in a second. It could be greater than, it could be less than, or it could be equal to. But in this case, what was it? 100 plus 49 was equal to 149. So A plus B is equal to C at that point, or C squared. A squared plus B squared is equal to C squared. Because these two totals, 149, they equal 149, they equal to 149. So both sides of the equal sign are equal to one another. They're balanced. So in this case, A squared plus B squared is equal to C squared. And let's check all of our work now. Correct. So just a little bit of math you have to do. So make sure you have a calculator, or you can use your phone. It really doesn't matter. Or you can use your computer. There might be a calculator on the computer. Just because these are a little lengthy, I think I'm going to stop after this example for the first 10, that is. So let's look at 11, because 11 through 15 are going to be the same. I need to erase all this now too. Erase. Okay, just for the sake of time, let's just not worry about the rest of that over there. Okay, now below are two triangles with their side lengths shown. Answer the questions about each triangle, okay? So now this is a little bit different, still Pythagorean theorem, but we're using the side lengths to determine what kind of triangle we're looking at, an acute, a right, or a obtuse triangle. So You know what? Let me actually just erase this because this is going to be important. What I write, I'm going to write some stuff down here. Let me just go ahead, erase, 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 erase. Okay. All right. So here we go. You're going to answer the questions about each triangle. So, listen. Oh, why is it doing that? Okay, so let's look at the left side. Compute the sum of the square. Compute the sum of the squares of the shorter lengths. Okay, so we know 12 squared, or I know right off the bat, is 144. So, should I write this out? Yeah, let's just write it over here. 144. Man, this this is like the hardest thing in the world to do right now. Is write with this. 144 plus 16 squared. I know 16 squared is 256. So 144 plus 256. They want to know what that's equal to. So 256 plus 144 is 400. 256 plus 144 is 400. 400. So the next it says, so I guess we can write that out. Oops. So it's 400. Then next it says to compute the square of the longest length. Compute the square of the longest length. 20 squared. What is 20 squared? Because if we take the square root of all these sides, the square root of all these sides, the square root of 144 is, square root of 144 is 12. And then the square root of 256 is 16. And then the square root of 400 is 20. Is 20. Let's just erase this actually. Because 16 plus 12 is not 20. Just draw a little line in between them. Okay. So they want us to compute the square of the longest length. And we kind of just did that already. So 20 squared, we know is, or we don't know, but we added, if a squared plus b squared is equal to c squared, if that's the case. Let's see, 144 plus 256 was 400. We take the square root of 400, that's just 20. So 20 squared, it's going the opposite. 20 squared is 400. So 20 times 20. 20 times 20 is 400. And now they want to know what kind of triangle. And this goes back to the end of that last example where they wanted to know if a squared plus b squared is greater than, less than, or equal to c squared. That'll tell us what kind of triangle. And let me write all this information out for you right now. If we have an acute, this is going to be tough. If we have an acute triangle, if we have an acute triangle, a squared plus b squared is going to be greater than c squared. If we have an obtuse triangle, c squared is going to be greater than a squared plus b squared. C squared will be greater than a squared plus b squared. And if I rearrange this like up here, it'd be a squared plus b squared is less than c squared, because if c squared is greater than a squared plus b squared, then a squared plus b squared is less than c squared. Hopefully that makes sense. So we can tell what type of triangle we're dealing with just by adding a squared plus b squared and seeing if it's greater than, less than, or equal to c squared. So we know a right triangle is a squared plus b squared is equal to c squared. So I didn't need to write that out. A squared plus b squared is equal to c squared if we have a right triangle, okay? So let's do the math. Is a squared plus b squared equal to c squared, greater than c squared, or less than c squared? And I think we already answered that. We did 12 times 12 was 144. 16 times 16 was 256. And then we added that together and we got 400. So a squared plus b squared is equal to c squared. And then we can look at this angle right here. These two legs form to make a right angle right here. So we know just by looking at that right angle that we have a right triangle. Okay, next. Compute the sum of squares of the shorter lengths. Now we have 8 squared plus 11 squared. What is 8 squared plus 11 squared? I know 8 times 8 is 64. And I know 11 times 11 is 121. So what is 64 plus 121? That is 185. So 8 squared plus 11 squared is equal to 185. I compute the square of the longest length. The longest length of this triangle here is 12. So what is 12 squared? I know 12 squared is 144. What kind of triangle is this? So let's take a squared plus b squared and see if it's greater than, equal to, or less than c squared. So this is a squared plus b squared equals this, and c squared equals this. So is a squared plus b squared greater than, less than, or equal to 144? Hopefully you say a squared plus b squared is greater than 185 is greater than 144. So if a squared plus b squared is greater than c squared, then we're dealing with an acute triangle. An acute triangle. And then, just to recap, a squared plus b squared was 400 and c squared was 400. So a squared plus b squared was equal to c squared, right triangle. So we have an acute and a right triangle. Let's see if we're correct. We are correct. So I know this is kind of lengthy. I apologize because I myself don't like watching long videos, but this will be very helpful for you. If, like always, if you have any questions, email me. Send me a comment through Alex. Send me a comment through Google Classroom. If you want to set up office hours, they're every day from 12:15 to 1:15. But you got to let me know early. But other than that, hey, this is the last assignment. Thank you to you who logged in every week, did your work every week, and strive to be better. Because I know some of you took these homework assignments more than once. You might not have did well the first time, but you kept persevering, and you did it right the second time. Mostly everybody's getting 100s on these assignments. So that's letting me know that you're paying attention. If you don't do well, you're taking the initiative to go ahead and redo it. And I appreciate that because we didn't have a lot of participation, which is understood, but I just really appreciate you taking the time to come in and do these assignments every week. So I'm going to stop talking. And, I wish you guys the best. I hope you're doing okay. And I'll talk to you soon.